Okay, so today we're going to be looking at exponential modeling in context. So we're going to be looking at word problems. So like I said, if you want highlighters, there's highlighters up here. So our objective as students will be able to use exponential models to solve context problems. So we're going to be looking at exponential growth and exponential decay today. If we look at the prior knowledge here, it says we have the number of bacteria in a petri dish can be modeled by the function b of t is equal to 50 times 4 to the t power, where t is in hours. And then the question is, how many bacteria will there be when t is equal to 1/2? So my function b of t is given, and it's representing the number of bacteria. I am looking for how many bacteria there are at when t is equal to 1/2. So basically, if we look at our function, the only variable we have is t, and they're giving us t. So basically, all you got to do is plug in t, okay? So we have the b of t, which t is 1/2, is equal to 50 times 4 to the t power, and t is 1/2. And so if you look at this 1/2 power, if you remember changing from exponential form to radical form, if I had like b to the n over p, no, it was written different. It was p over n, sorry. P over n. We could change it to the nth root of b to the p power. Do you guys remember that? Yes, no, maybe so. I'm talking about this over here. Do you guys remember changing from an exponent to a radical form? The whatever's in the denominator is your root, and whatever's in the numerator is your power. So if we look at this 4 to the 1/2, this 1/2, my denominator is my root. So because that's a 2, then that means this is a square root of 4. That 1/2 really means the square root of 4 raised to the p power, but p is 1 here, so it's just raised to the first power. So it's basically the 1/2 just means square root of 4, okay? All I did right now is I changed the 1/2 into a square root, basically, is what I did, okay? That's because this p, and if you ever have something raised to a fraction, you could change it to radical form like this. The denominator is the root, and the numerator is the power. So in this case, my root is 2, so square root to the first power, so I don't do anything with the first power. It's just square root of 4. So what is the square root of 4?
Square root of 4 is 2.
2,
That's
and
100.
50 times 2 gives us 100. But then this is a word problem. So because we have a word problem, we have to write a sentence conclusion. What is this 100 representing? So how much bacteria we have when t is 1/2. Good. So there would be 100 bacteria when t is equal to 1/2. So in today's example, we're going to be doing this where we'll be given a t, and then we have to just plug it in and solve, essentially. But the beginning of the examples, we're going to have to actually create a function first, and then in the part B's, we're going to be plugging in a value. Okay, so for today's concept, we're going to be looking at exponential growth and decay. So exponential growth function has the form f of t equals a to the 1 plus r to the t power. So we are going to be seeing this 1 plus r in the equation. It's a plus because it's a growth. We're increasing. And it says R is the constant percent increase expressed as a decimal for each unit increase in time. But then we have also the A in the function. So A is representing the initial value. R is the percent increase. But because we're looking at percents, we can't do any calculations as a percent. So you have to change this as a decimal. And then it'll give us T in some unit of time. And A is the initial value. And then the growth, if we go from left to right, it should be going uphill. Exponential growth, it's increasing, okay? And then if we look at exponential decay, in my function, it changes to 1 minus r instead of 1 plus r. And then my A is still the initial value. R is the percent decrease this time. And again, we can't do any calculations with percents. We have to use it as a decimal. Yes? Yes. For each unit increase in time t. So if we look at our graph is actually going downhill this time. So the downhill means it's a exponential decay. It's decreasing. So the difference in my equations is the growth has a 1 plus r. The decay has the 1 minus r. So let's look at our first example here. Our first example says Tony purchased a rare guitar in the year 2000 for $12,000. Experts estimate that its value will increase by 14% per year. And then our part A says write a function using the model v of t equals a times parentheses 1 plus r to the t to find the value of the guitar t years after it was purchased. So my important information I have is the year 2000. I have this 12,000 and I have this 14% and it's going to be increasing. Because it's increasing, my equation has the 1 plus r instead of the 1 minus r. And so if you remember, A is the initial value and then r is the rate increase and then t is like the unit of time. So if we look at my context, what is my A value? What's the initial value of the guitar? How much did Tony pay for the guitar? 12,000. So this 12,000 is my A value. My A value is $12,000. And then I need to know what's the R. So my R is the rate as a percent. So in this case is the 14%. So my R is 14%. But I need to have the percent as a decimal. So as a decimal, you can move the decimal over 2 times to the left, or you can take your percent and you can divide by 100. Like 14 divided by 100, and it's going to give you a decimal. So my R is really going to be 0.14. You can move the decimal twice over or divide by 100, and that gives you your percent as a decimal. So I have my A and I have my R, and I'm going to leave the T because I don't have my actual T value yet. So now I can just write my equation or function. It's going to be V of T is equal to my A value, which is 12,000, times parentheses 1 plus my R, which is 0.14. And I'm going to raise that to the T power. So simplify, this is V of T equals 12,000 times parentheses, what's 1 plus 0.14? That's just going to be 1.14 to the T power. So this is my answer to part A. All right, then for my part B, it says estimate how much the guitar will be worth in the year 2009. So I need to look back at my context problem and see what does T stand for. So T is years after it was purchased. So what year did Tony purchase the guitar?
2000.
In 2000. So in 2009, how many years have passed? 9 years. So T, we would do 2009 minus 2000. That gives us 9 for our T. So then now I'm going to go plug in anywhere I see the T in my function. I'm going to go plug in 9. So I have V of 9 is going to equal 12,000 times 1.14 to the T power, which is 9. For your calculator, you basically type it in just like you see it. You're going to type in 12,000. Then you're going to open a parenthesis, go 1.14, close the parenthesis. And then you need the caret key. The caret key is on top of the x squared. It looks like this, like a little teepee or tent. And then you're going to put 9 and equals. So you have a little caret key or a tent key up above the x squared. Press 9 and then equals. And you should get a pretty large number. Okay, double check your answer with your partner. What did you get in the calculator? Did you guys double check with somebody? All right, Jasmine, can you tell me what did you get for your answer? You didn't do it? Omar, did you get the answer?
Yeah, I got a bunch of numbers.
Yeah, just tell me what they are.
39023.
Point, just 2 more.
38.
38? Okay, thank you. All right, so we got 3,923 with 38 cents. So we're talking about money, so that's why I rounded to the hundredths place, because it's like our cents, the 38 cents. So we have the guitar would be worth about $39,023.38. Okay, so we have to write our sentence conclusion. We're going to say Tony's guitar would be worth about $23.38 in the year 2009. All right, so let's go ahead and look at our next example. This time we had to subtract to find T. So let's look at our next example. Our next example here says we have a certain stock opens on the market with a value of $29.32. And it says over the 4 days, the value of the stock increases at a rate of 5.5% per day. We're supposed to write a function to model the value of the stock using the function S of D equals A times 1 plus R to the D power. So remember, we need to figure out what are A and R. See if you guys can work together to figure out what are A and R here. For my R, again, we can do divided by 100. So my R is going to be 0.055. Or you can take the decimal, move it over twice. All right, so we have S of D is equal to my A value, which is $29.32, times parenthesis 1 plus my R, which is 0.055, raised to the T power. And then just simplify what's inside the parentheses. So we have S of D equals $29.32 times 1 plus 0.055 is going to be 1.055 to the T power. And that's going to be my answer to part A. Part B says, if this trend continues, how much will the stock be worth 1 week later? 1 week later. But in this case, you have to go back and look at the units. This is talking about weeks, but my increase is increasing per day, not weeks, right? This says per day, but this says 1 week. So I need to figure out how many days are in 1 week. In 1 week, there's how many days? 7 days. Okay? That means that my T, in this case, is going to be 7. So I'm going to go plug in T to my function. Oh, I just realized that the function here had D's instead of T's. But it's the same thing. It's just a different variable. But I didn't realize I didn't put a T here. My variables weren't matching. The T and the T. So I'm going to change this to T's. You can change both of them to D's, it's fine. But I'm going to stick to T's just so it's the same every example. But T is in days, so I think that's why they did D. All right, so we have S of 7. We're going to plug in 7. It's going to equal $29.32 times 1.055 raised to the T power, which is 7. Okay, so again, you're going to grab your calculator, and then you guys all need to practice this. So grab your calculator. You're going to do $29.32, so 29.32. You're going to open a parenthesis, then 1.055, close the parenthesis, and then to get to the power of 7, you're doing the caret key that's on top of the x squared. You're going to use this caret key, and then you put the 7, and then press equals. So 29.32, open a parenthesis, 1.055, close the parenthesis, and then you're going to go to the power of 7 and press equals. Okay, and go ahead and share with your partner what did you guys get for your answer. Think again, you're talking about money, so round to the nearest hundredths, the cents, please. All right, what did you guys get for your answer? Anybody?
42.65.
$42.65. Okay, thank you. And what is that representing?
Representing the value.
The value of the
Stocks
stock.
being produced.
So we're going to say the stock will be worth about, okay? So we're going to say the stock would be worth about $42.65 after 1 week. All right, so I'm going to have you guys go ahead and try the next example on your own here, and then I'll show you guys the solution after. I'm going to be walking around to check your work and help as needed. All right, so again, here's the solution. You have to figure out what, for part B, what unit of time are we talking about? In this case, it was years, so we plug in T for years, so we had to plug in 40. All right, so now let's move on to exponential decay. So exponential decay, things are going to be like losing value instead. So in this case, we have the value of a truck purchased new for $28,000 depreciates by 9.5% each year. And we're supposed to write a function for this situation using the model v of t equals a times 1 minus r to the t power. So this word depreciates basically just means it's losing value. It's decreasing. And so because it's decreasing this time, we're using the 1 minus r instead of 1 plus r in the equation. Okay. But I still need to know what's a and r. So my a value is still the initial. So how much did or how much is the truck new? 28,000. So 28,000 is my a value. That's how much it's worth brand new. Then my r is still the rate, but this time it's decreasing. So what's the rate of decrease? That's still my percent over here is r. So my r is 9.5%, but I don't want it as a percent. I want it as a decimal. So again, you can divide by 100 or just move the decimal twice. Now you're going to have to add a 0 in front of the 9. So the r is going to be 0.095. So then just plug it in. We have v of t is equal to the a value, which is 28,000, times parenthesis 1 minus r, and r this time is 0.095 raised to the t power. So I have v of t is equal to, simplify the parenthesis part, so 28,000. What's 1 minus 0.095? You guys put that in a calculator. What's 1 minus 0.095? You should get something less than 1, so it should be a 0 point something. Yep. 0.905. Thank you. Raised to the t power. So this is now my answer to part A. It's a decay, so because it's a decay, this is less than 1. First, all the other examples we had were 1 point something. It's a growth, but a decay, it's actually going to be smaller than 1. And then for part B, estimate how much the truck will be worth 12 years after it was purchased. So in this case, my T is in years, and I have 12 years. So I know in this case, T is going to be 12. So I'm basically just going to plug in 12 everywhere we see a T in my function. So I have V of 12 is going to equal 28,000 times 0.905 to the 12th power. And you're going to just plug that in the calculator just like we've been doing. So 28,000 parentheses 0.905 to the caret key 12th power, and then press equals. And go ahead and share with your partner what did you guys get for your answer. Remember we're talking about money, so you wanted to round to the hundredths place, your cents. All right, let me call somebody. Alexa, what did you get for your answer?
845. No, 8,451.63.
63?
Yeah, but it has a 9, so 64.
64 cents. Okay, good. So $8,451.64. So for my sentence, we can say the truck would be worth $8,451.64 after 12 years of purchase.